Should start, I think. There it goes. It's recording now. All right. All right, so here we go. Let's do section 5.4. This thing is called complex numbers. Actually, today we're really technically not going to talk about complex numbers. Tomorrow, we're going to split this lesson up into 2 lessons. All right. And the first part, we're not technically going to talk about complex numbers, but we're going to talk about something that you need to know in order to do complex numbers. Okay, so that's just the title of the lesson. So let's talk about something first. If you look in the book, let's see, here's the book. If you look at the book, that's the name of the lesson right there, but we're going to talk about this thing, imaginary numbers. They call it a pure imaginary number. I'm not sure why they call it a pure imaginary number, but that's what we're going to talk about. So if you look at it, the imaginary unit I, that's what we're going to discuss right now. So I did put this chapter of the book under files. So if you want to follow along, you can. Or when we get to the homework, you should be able to do your homework because this exact thing is on Teams under files. All right, so if you have any problems finding that, just let me know. It's pretty easy. Just go up to the top, it says files, you drop down, and it's a PDF. Like the little icon is reddish kind of a color, and you would just find the one that says Glencoe. I think it says Glencoe Algebra 2 or something like that, and it will you'll be able to see the whole entire book. You can actually download it from there as well. I believe if you look around, there's a place where you can actually download it to your computer, so you don't just have to use Teams to see it. All right, enough of that. If you have any questions, again, let me know. All right, let's talk about that thing that book says. It's called the imaginary. I'm just going to call it an imaginary number. And you think, what in the world? Are we just kind of dreaming up a number? Is that what we're doing? Well, we're not. I'm not really sure where they got the word imaginary number from. And people ask me all the time when I teach this stuff, or when I used to teach this stuff, why in the world do we have to know this? I mean, imaginary numbers, it's not even a real number. It's an imaginary number. So why would you use this? Well, several years back, I had a kid that I taught, it was a bunch of years back now, and he was an engineer for Boeing. He worked on helicopters, like military helicopters. And I was asking him, I said, do you ever use imaginary numbers? Because he was an engineer. He got his engineering degree. He says, oh, Mr. Hamrick, we use it all the time. He says, you wouldn't believe how much we use it. And I'm not sure. I can't really tell you because I'm not an engineer. I can't tell you exactly how it's used. But he said in like electricity and things like that, imaginary numbers and complex numbers are used all the time. So I take it from him that this is a really useful thing eventually. Now, just learning this in high school, you're not going to go out and get a job that uses imaginary numbers, but they are useful, so that's why we're learning it. All right, so let's take a look. So they use the letter I, makes sense, doesn't it, for imaginary numbers? They use the letter I to represent an imaginary number. So they define the letter I. It's not just a variable. Usually when you see an I or an A or an X or a Z or something like that, it's usually a variable. It could stand for any number at all. But the I right here specifically stands for a particular number, and it's not even a real number. So what it is this. It's kind of weird. It's the square root of -1. This is probably the first time, I would guess, that you've seen imaginary numbers. I don't think you did this in Algebra 1. I'm almost positive you didn't do this in geometry. So this probably is the first time that you saw imaginary numbers. So I found a calculator online. I just thought we would throw the square root of -1 into the calculator and see what's going on. And as you probably already know, we're not allowed to have square roots. That's what we've been taught, right, our whole lives, that we can't have a negative number inside of a square root. But here's the first time where we actually can. We can actually have a negative number inside a square root. So let me bring that calculator up. So here's a calculator. And what I'm going to do is I'm going to put the square root of -1. So I put a square root, I put -1, and then if you look over here, this is your answer. It says it's undefined, which means it doesn't exist. All right. A calculator only gives you real answers. So this calculator is not going to give you a real number answer because this is not a real number. This is an imaginary number. right? You're thinking, what in the world's going on, Mr. Hamrick? Well, I agree. It's kind of weird. But we're going to learn how to work with them. It is kind of weird. It looks strange. It goes against everything that we were taught, that you can't have a square root or a negative under a square root. But it's something that we can work with, and it's really not that hard to work with. You're going to find that this lesson is pretty easy when you're actually doing the math part of it. Now, here's an important thing. A lot of times you're going to see I, and you're going to see that I is going to be squared. So if we square I, it actually comes out to a real number. It doesn't come out to an imaginary number. So if I square I, it actually comes out to a real number. So what happens if we square something? Well, I was square root of -1, correct? Yes. So if you square that, put a little square right there, what happens to the squared and the square root? Anybody want to talk to me? Somebody give it a shot just so I know somebody's there. There, I got all you guys there. So all these people are here. So somebody talk to me. Anybody want to talk to me? Cola, I see you. Unmute yourself and talk to me. So,
Oh boy. Okay.
what happens when you square a square root? What happens?
It kind of like cancels out, so you're just left
Exactly
with the
right.
base number.
Yep, exactly right. And they do. They cancel each other out. Now, some math teachers are real particular about they don't like saying they cancel out, but really that's what they do. And you're left, and just like Cola said, you're left with this base number or this number that's inside the square root, so it's equal to -1. That's a really, really important thing. So let's make a little bit of a list here. So I'm just going to put a 1 right there. So I to the first power is just the square root of -1. So if I take I squared, that's equal to -1, right? Because I squared the square root, they cancel out, I'm just left with a -1. Let's do a couple more. What about I cubed? What in the world is I cubed? Well, I cubed, let's just do this off to the side, is the same as I squared times I. I think you would agree with that, right? Because you got two i's. Whoops, why did I put a square there? I don't know. So it's I squared times I, or I to the first. So if you simplify that, we already found out that I squared is -1, and then this is just I, which is the square root of -1. So if I write this real nice and neat, it's negative square root of -1. All right, so that's kind of weird. Or I'm not just going to write that. If you look at this, what is this? That's I, isn't it? So I cubed is the same as -I. So that's what I cubed is equal to. It's -I. All right? Hopefully you follow me on that one. Let's do one more. Let's go I to the fourth. This is actually a little easier, I think. So I to the fourth. Let's break it down again into I squareds, because we know that I squared is equal to -1. So if we can break all these things down into squareds, it's going to make it really a lot easier for us. So if I take, I squared times I squared, right? That's I to the fourth, right? Because you add the exponents, right? That's an Algebra 1 topic. When you multiply bases with exponents, you add the exponents if you have the same base. All right, so I squared, we just found out, that's our definition. I squared is -1, so that's going to be a -1 right there. And this I squared is also -1. Well, that's easy. -1 times -1 is +1. So you come over here, I to the fourth is just +1. So this stuff right here is really important, okay? I would memorize them. Now, do you have to memorize it? No, you could always figure this out. If you don't remember what I cubed is, you could always come over here, break I cubed down into I squared times I, work it out. That's -1. That's just I, or you could write it square root of -1 if you wanted to, or just keep it -I. So if you memorize these, things go a lot quicker. If you can't memorize them, it's fine. You can always work it out just like we did here. But definitely I squared you should have memorized. That's pretty easy, -1. All right, so that's kind of where we're going with this. Now we're going to do a bunch of stuff with these, and let's see, what do I want to, yeah, let's just go right to the example now, okay? And let's take a look, see if anybody's still there. All right, any questions on that? Do you have any questions on what we've done so far? I can't get everybody else's picture on there. I don't know how to do that. It's for some reason it only shows so many people's pictures, but that's okay. Are we good? All right. All right, stop me if you have any questions, all right? Because I have no idea. I'm just talking to a, I'm just in my basement. I'm just like talking to a screen by myself. It's be nice to have a little interaction. So if you have any questions, please let me know, okay? All right, everybody good? Give me a thumbs up. So people online, give me a thumbs up so I can see you. There you go. You like my background, by the way? Isn't that cool? My I'm in this little room in my basement, and my room is just a mess. I'm like, so I tried to put a blanket up behind me to make it look nice. I thought, oh, I'll just do one of these crazy backgrounds. All right, enough talk. Let's keep going. All right, so let's do an example. Let's change colors. I'm tired of that white color. Oops, do this. Look at all these colors I got. Isn't this cool? You're like, yeah, sure. Let's go green. I like that green. All right, so let's do this first example. So here's kind of stuff they're going to ask you at first. So this is example 1. Um, all these basically just say simplify. So what they're going to do is they're going to give you an expression. It's not really an equation. It's just an expression. First one is the square root of negative 27. All right. So the square root of negative 27, we want to simplify it. Well, let's take a look at this. You got a negative inside the square root. Again, we talked about this already, that you're not supposed to have negatives inside square roots, but we have learned imaginary numbers, so we can actually work with this and we can simplify this so that we don't have a square root. I'm sorry, I keep saying that. We don't have a negative inside the square root. That's what we're trying to do here. So what I'm going to do is I'm going to break this up. Now, you've actually done some of this stuff in Algebra 1. For instance, let me just take a little sidebar here. Like if I ask you to simplify square root of 8 in Algebra 1, this is what you did. Okay, you said, well, 8 is the same as 4 times 2. All right, and what you can do, here's a basic rule of algebra, that you can break this product into individual square roots. It's the same exact thing. All right, we have a rule that says we can do that. Now, the reason I used 4 and 2, well, there's nothing else except 8 and 1, but what happens when I get the square root of 4? I just get a plain old 2. You can't do anything else with that square root of 2. You can't simplify that any further. You're not going to put it into a calculator and get a decimal answer. We're just going to leave it in terms of the square roots. So if I ask you to simplify the square root of 8, this is how you would simplify the square root of 8. Well, let's go back to this. We're going to do basically the same thing, but the only thing different here is that we got that negative right there. But that's okay because we know what to do with a negative inside the square root. So I'm going to put a negative 1 right here because it's the negative 27, so that's my negative 1. Extend that a little bit. So let's think what times what is 27. And what I want to try to do is I want to try to pick a number that I can take the square root of, and it comes out to a whole number. So really, there's no other choices but 9 and 3. All right, so I'm going to put times, oops, supposed to be a little dot. I don't know why I did that. So 9 times 3. What's that word? What's it doing? That's weird. There it goes. All right, so what we're going to do is we're going to break this down. Now, I know what the square root of 9 is. It's just a whole number 3. So that's going to come out front. But I also know what the square root of negative 1 is. But let's break these down. Just like I did this, I'm going to break it down into its individual square roots. There's going to come a point, it should be pretty soon, that you don't have to do this, that you don't have to break these down. You should be able to go from here to here in your head. All right? You might be able to leave this step out. All right, you don't want to always show every single step because it would take you forever to do problems. So that's what I would do. I would leave this step out. I see this as a square root of 4 is 2, so I put it right there. I'm left with the square root of 2, and I stick it right there. So let's do the same thing. Well, let's do the steps since I'm teaching it to you for the first time, but eventually you should be able to do a little bit of this in your head. So what I'm going to do is break this down into its individual square roots. So that's the square root of negative 1. This is the square root of 9, and this is the square root of 3. All right, so let's simplify this. Well, we know what the square root of negative 1 is. We just talked about that, and that's just the letter I. And that's what we do. When you ever see a square root of negative 1, you write the letter I. Now, the square root of 9 is 3, so these are all being multiplied, so I'll put a dot right there. That's being multiplied by 3, because the square root of 9 is just a plain whole number 3. It's not the square root of 3, it's just 3. Now, the square root of 3 right here, I can't simplify that any further, so I just keep it the square root of 3. That looks like it might be your answer, but here's the notation. This is how we write our notation correctly. All right, so if you have something like this, let's see, yeah, it depends on the teacher, I guess, and the book. But this is how I would write it. I would put the 3 first, the whole number first, then I'd put the I, and then if you have a square root, I'd put that at the end. Now, some teachers, I'm going to put an or right here. I've seen some books or teachers write it like this: 3 squared to 3i. I don't like this because sometimes you could get confused that that I might be under that square root. Right here, the I is not under the square root, but if people are a little bit sloppy and that goes over a little bit further, then people would think that I is under the square root. So just to make sure that we don't think the I is under the square root, we stick it here out front of that square root of 3. So I'm not going to write it like this. Technically, that wouldn't be wrong, but I want to write it like this, and that's going to give me my answer. All right. Let me take a look. Guys still awake? All right. Everybody's watching? All right. So if you have any questions, please stop me. All right, because I want to know that you guys are listening and paying attention. All right, let's keep going. If there's no other questions, if there are, just holler out to me. And let's push. Let's do this. Oh my goodness, what did I just do? Let's do that. There we go. All right. Just getting the hang of all this. Let's do another one. This one's same kind of thing, except this is, this is example 2. So this is example 2. So it's the same kind of thing. The number is just a little bit more difficult to work with. All right, so it's negative. It's the square root of negative 216. So what I would do here is this. First of all, you got a negative inside of there. So I'm going to show all the steps right now. So you got a negative inside of here, and then you got to figure out what in the world's 216. Well, 216 is not one of those kind of numbers that just pops in my head. 27 was easy because I know my multiplication tables, right? So it's 9 times, what did I say, 27? 9 times 3. So I knew that off the top of my head. That was easy. 216 is not a number that I'm really familiar with. But what I would do is I'd put it in my calculator, and let's go back to the calculator. Let's get rid of this. All right, so 216. Now, I know very easily that this is an even number, so you can divide it by 2. So let's see what we get when we divide it by 2. It's 108. Well, let's see, I've never used this calculator before. Can I divide it by 2 one more time? Let me see if that works. Divided by 2 again. I don't know if that, no, that's not it. All right, so it's 108, but you, let's just start from scratch. Let's see. Can I do this? Oh, sorry. I should have learned this calculator first. Let's do this. So it's 108. So let's do 108 divided by 2. Like if you had a real calculator. Let's see. And divided by 2. There we go. It's 54. So what do I got? I've got 4. I divided by 2 twice. So I've got 54 times 4. Am I doing that right? Yep. And then you could go do, let's do this. Let's go back again. Let's go 54 divided by 2 again. Let's see what we get. And that's 27. So, I'm not going to do that. Forget that. Forget that I did any of that stuff. Let's go back to this. Here's a number. What I would do, though, you could do that. You could put all those numbers in and then figure out what it's equal to. But here's an easy one. If you stick it in your calculator, you're actually going to get 36 times 6. So 36 times 6 is 216. All right, sorry about all that mess. I just wasn't familiar with that calculator, and I just lost track of all the numbers that I was dividing by. So, but if you put it in your calculator, 36 times 6 is the same as 216. So what I'm going to do now is take the square root. Let's not even do that. Yeah, let's do that. I'll put the square root of -1. So I'm going to take these things. If they're all being multiplied together under a square root, I can pull those out of the square root. So I'm going to take the square root of 36, and I'm going to take the square root of 6. 36 works great because I know what the square root of 36 is. It comes out to a nice whole number. So let's write this down. We know what the square root of negative 1 is. It's I. That's really the only new thing that we're learning today. The square root of 36 is 6, and then square root of 6. Do we write it like this? I've seen some books that put the I out in front like that, but I think we want to be consistent, and our book does this. It puts the whole number first, then the I, and then the square root. So this right here is the same exact thing as that right there. Now, you can't put this into a calculator because calculators only understand real numbers. So you can't put it in a calculator and check to see if it's the right answer, but that is correct. All right, so that was a little weird. But simplifying is really not that big of a deal if you know how to break down these square roots. Again, supposedly you learned that in Algebra 1. If not, I showed you how to do it today. I showed you how to do all the little steps to it. Okay, so hopefully you understand that. Again, for the 10th time, if you have any questions, please stop me and let me know. All right, I'm going to keep going. I'll trust you. That actually wasn't example 2. That was actually 1A. This one's actually example 2. I wrote it down wrong in my notes. So here's another one. It's going to be simplify. It's going to be a little bit different, though. It's going to take some of the stuff we've already learned, and it's going to combine it into this. So watch. I've got a negative 5i, and they put a dot for times, multiply by 3i. This is probably easier than the first two that we did. So you're just going to multiply these things together. All these things are being multiplied. Negative 5 times I times 3 times I. So first thing, let's do our whole numbers, our regular numbers. So that's pretty easy. Negative 5 times 3, which is negative 15. Now here's the new stuff. I got an I times I. So anytime you multiply something by itself, what do you do to it? You are squaring it. So that should look familiar. We've talked about this a lot today. Put an equal sign here, equal sign here. So I've got a negative 15. I squared is negative 1. So you just memorize it. I squared is negative 1. And now you multiply these. Negative 15 times negative 1 is positive 15. And that's it. That's all there is to it. Pretty easy. Let's try another one. Let's try this color. So that was example 2A, and this is example 2B. So again, we're going to simplify. But here it is. It's negative, square root of negative 6 times the square root of negative 15. Here's what we're going to do. We're going to combine this a little bit. Do you remember when we had that square root of 36? Worked out really nice and gave us a whole number. I kind of want to see where that's going right here as well. So first thing I'm going to do is this. I want to break down 15. So if I break down 15, what are the multiples of 15? Well, it's 3 times 5, or the factors, I should say, of 15. It's 3 times 5, all right? And right here, I have a 3 times 2. So I have a 3 in here, and I got a 3 in there. 3 times 3 is 9. Square root of 9 is 3. I know I went a little quick, but let's write it down. So we got a negative 1, first of all. I'll tell you what, I'm going to watch this. I can shorten that a little bit like that. It's pretty cool, huh? All right, so what I'm going to do is I'm going to break these down into their, let me grab the purple. There we go. So what I'm going to do is break these down into their individual square roots. So I'm going to take this and do a little bit in my head. So in my head, I'm just going 3 times 2. It's really not that big of a deal. So I'm going square root of 3, and I'm going square root of 2. Right here, I'm going to break that down. So I got that negative. That's the square root of negative 1. And then what times what is 15? 3 times 5. So I'm going to go the square root of 3 times the square root of 5. This right here is the same thing as this. You're probably thinking, Mr. Hammer, you made this way harder than what it was up there. Not really. I made it a lot easier. So first of all, let's do this. Let's take a look at the square root of negative 1 here and the square root of negative 1 right there. They're multiplied together, so they're squared. So what's the square root squared? It's just I squared. So this is an I, this is an I squared is negative 1. Hopefully you should be able to do that in your head, okay? You realize that that's an I, you realize that that's an I I times I is I squared. I squared is -1. All right, so we're done with that part of it. Now let's look at what we have right here. What I like to do with square roots, I like to see which ones have the same base, right? This has the base of 3, and this has a base of 3. So the square root of 3 times the square root of 3. Let's just do this in our head a little bit. So the square root of 3 times the square root of 3 is the same thing. You could just put it under one big square root and multiply those together. That's a square root of 9. Or you could look at it like this. The square root of 3 times itself means you square it. Either way, you're going to get the same answer. Look at this. What's the square root of 9 is just a positive 3. What's the square of the square root of 3? That cancels with that, and we're still left with a 3. Once you get the idea of that, you should just be able to look at these. You should be able to look at square root of 3 times square root of 3, and you're like, oh yeah, that's just 3. It's not the square root of 3, it's just the whole number 3. So I'm done with that. What else do we have? I got the square root of 2 times the square root of 5. Well, the square root of 2 times the square root of 5, I can put those both under a square root and multiply 2 times 5, which is 10. Let's clean it up a little bit so we don't have that little dot right there, but basically this just equals -3 times the square root of 10, and that is your answer. It's the same thing as this right there, okay? All right. Any questions on that? Now's the time to ask.
Mr.
Yes, got a question. Good.
So when we get to having like bigger numbers with those problems,
Yeah.
like when they'll have like more than one multiple we can choose from, which one do we choose to break up?
Choose the one that you can break up. That sounds like a terrible answer, but let's go. I tell you what. Let's go back to that square root of 216. Okay, so this is a bigger number. Is this kind of number that you're talking about?
Yeah.
Okay, so now, I went through and I said, okay, just think 36 times 6. Well, you may not have known that 36 times 6 was 216. So if I was going to do this completely from scratch, okay, let's do this in a different color. Let's go a little bit brighter. Let's go this color right here. Okay, so, oops. Now, we do know that 2 goes into this, right? Now, watch. I'm going to write a bunch of stuff here that you don't necessarily have to do. You could do a lot of this in your calculator, but I'm going to do it here. So I could write 2 times. Now, if I divide this by 2, what do I get? I get 108. Okay? Let's keep going. Keep it under the square root. Let's take 108, divide that by 2. It's an even number, right? So we divide that by 2. So there's another 2 times 54. That's easy. You should, 10 divided by 2 is 5. 8 divided by 2 is 4. It's easy to do in your head. All right? So let's keep going. So you got a 2 here. You got a 2 here. What about this 54? It's an even number, so we know 2 goes into it. Any idea how many times 2 goes into 54? Well, you could always put it in your calculator. And I believe it's 27. Okay? Scooch this up a little bit. Let's keep going. Now, there's better ways to do this, but I'm just showing you what you can do here. So there's my 2, 2, and 2. So that's 27. Let's break down 27. Well, we already did 27 earlier. Do you remember what that was? That was 3 times 9. Now, to tell you the truth, I'm not even going to take 9 and break that down any further. If you wanted to, you could. So you'd have a 3 times 3 times 3 here if you wanted to do that. I tell you what, let's just do it. Just for the fun of it. I'm going to break it down like as small as I can get it. All the way into its prime factors is what they teach you in Algebra 1. Okay? Hopefully you see where we got all this stuff. See, this is 2 times 108. This is 2 times 54. This is 2 times 27 is 54. This is 3 times 9 is 27, and we just keep bringing everything else down. And right here, I got 3 times 3 is 9. So if you take a look at this, what we can do is we can pair things up, because 2 times 2 is 4. I know what the square root of 4 is. Come over here. What else can we pair up? We can pair up these 3's right here. Okay, 3 times 3 is 9. The square root of 9 is 3. So let's go back to this color now. Watch what we can do. 2 times 2 is 4. It's under a square root. So what's the square root of 4? It's just plain old 2. So I'm done with that one. Let's do this one. 3 times 3 is 9. If I take the square root of 9, I get a 3. And I'm done with that one. What about this? 2 and 3. They're prime factors, okay? So they don't come out to a nice whole number. I have to keep them under the square root. So 2 times 3 is 6, but it stays under the square root. And now we can simplify this. 2 times 3 is 6 times the square root of 6. And that's what we got when we got that square root of 216. So you could take big numbers, sure enough. You could take big numbers. Now, if you realized right off the bat that this was 36 times 6, it would make it so much easier than doing all this work. But you could always take a big number, and you can always just try a number. If it's an even number, always try 2. All right. Then if it's not an even number, try 3. If it ends in a 5, try a 5. You know, that kind of stuff, and just keep working it out. And this is as long as I could possibly make this problem. Okay, you could do it a lot easier, but that shows you how you can take a big number and break it down like this. I hope that helps. Does it help? Whoever asked that?
Yeah, it does. Thank you.
Okay. Who's that? Morgan? Is that you?
No, it was Mia.
Mia. Okay. Hi, Mia.
Hi.
All right, let's do another one. Let's do example 3. So I think we're only going to check. Yeah, this is the last example. Let me just check my notes to make sure I don't stop early or I go too far. Come on, where is it? There it is. Well, give me a sec. Hold on. Yeah, we're gonna do a few more. Yeah, so actually, I lied at the beginning. I said we weren't going to do complex numbers, but I just checked my notes, and I thought we were going to stop early, but we are going to do some complex numbers. So let's try to go kind of quick here. Let's do one more example like this. You know what? I may stop after this one. I can do the rest tomorrow. All right, so what we're going to do now is we're not just going to simplify, we're going to solve. All right, so they're going to give me an equation. We're going to solve for x using the I stuff, okay, the imaginary number stuff. So here's the problem. 4x squared plus 256 equals 0. All right, so you've seen stuff like this before. First thing I would do is to see if there's a common factor. Is there a common factor with 4 and 256? Now, again, 256 is a number you may not be really familiar with, but you do know 4 goes, or you do know 2 goes into it. So try it again and see if 4 goes into it, and it does. Use your calculator if you need to. It's perfectly fine. So just for the sake of time, 4 does go into 256, okay? Just stick it in your calculator and see how many times it goes into it. So what I'm going to do is I'm going to factor out a common factor of 4. So they both have 4 in common. So it's, 64. All right, so 4 times 64 is 256. Again, it's not a number that you might know off the top of your head, but if you put it in a calculator, you can figure that out, okay? Now, if you remember from your Algebra 1 days, we can get rid of that 4, divide both sides by 4. So if I divide this side by 4, we get rid of it. If I divide this side by 4, what do we get? Well, 0 divided by 4, and 0 divided by anything is always 0. All right, so what I can do is I can write x squared plus 64 equals 0. So that wasn't too hard. That was just factoring out a greatest common factor. I'm sure, oh yeah, you just had a test on factoring, okay? So this was probably one of the easiest things that you know how to factor. Now you come over here, you got to get x by itself. So I have to get rid of that 64. Now here's something a little bit different that you probably haven't done before. So if I subtract a 64 from both sides, I get a negative 64. Now, in order to get the x by itself, I have to do the opposite of squaring. The opposite of squaring is taking the square root. So I got to take the square root over here. Now, this is the new stuff. Okay, everything else was old. This is the new stuff. So if I take the square root of x squared, I'm just left with an x. If I take the square root of negative 64, Okay, let's break that down as much as we can to simplify it. So I've got a -1 inside of there because of that negative. And then the square root of 64, I already know that. That's in my multiplication tables, isn't it? So the square root of -1 is just going to give me an I, right? That's the definition. And what's the square root of 64? It's going to give me an 8, because 8 times 8 is 64. Now, it's not, you could keep it like that, and you could probably get it right, but how do we write it? We always write the whole number first, and then the imaginary number after that. Okay? And that's all there is to that. That wasn't so bad, was it? Let me double check. I want to double check on your homework. I might have to do a couple more examples, but they're super easy, and I can do them in probably 5 minutes. Let's go back to your book. I just want to see your homework. It would be on page 280. So let's scooch down. Let's keep scooting to your homework. There we go. And I originally said 19 to 31. Yeah, we're going to have to do a couple more examples, okay? So let's just do that. Let's move on. So we've got 15 minutes. I'll try to do this a little faster. All right, let's go to a different color. Oh, look at that orange. That's a nice color. Let's try that. All right, so what we're going to do, let's talk about what a complex number is. I'm not going to get into the details of necessarily, why we need to know this. I kind of gave you a little preview on that before, but here it is. It's A plus BI. What in the world is this? Well, the A, a complex number, is the combination of a real number and this is an imaginary number. Okay, so this is sitting there by itself. It doesn't have an I attached to it, so that's a regular number, okay, a real number. This has an I attached to it or multiplied by it. We consider this the imaginary part, okay? We should say this. This is the real part of the complex number. This is the imaginary part of the complex number. This whole thing is not just two separate things, even though it kind of looks like it. This right here is one number, and it's considered to be a complex number. I took a class in college, and it was called complex analysis, a whole entire college course just on complex numbers, all right? So apparently it's pretty important if you're going to take a whole college class on this kind of stuff. So let's show you how to work it. It's super easy. I mean, this is basically like Algebra 1 stuff. It really is. So this is example 4. All right, so here we go. 3x minus 5 plus, and then they put this in parentheses, y minus 3, because it's being multiplied by this I. And then that equals 7 plus 6i. So they ask you to solve it. You're not just simplifying, you're actually solving an equation. You're solving for x and y. You're solving for both of them. Okay, now remember what the complex number is. It's a plus bi. So what we're going to do here is we're going to take all the all the real numbers, and we're going to put them all together. And then we're going to, do I want to say that? We're going to set them equal to each other, okay? So we're going to look at this left side, take the real part, set it equal to the real part over here. Then we're going to take the imaginary part and set it equal to the imaginary part over here. So that's what we're going to be doing. So if you take a look at this, let's just give you another color here. What's our real part over here on the left-hand side? Well, that whole 3x minus 5 is real. It doesn't have any i's attached to it, okay? So that must mean it's real. What's the real part over here? Well, it's that 7, right? Because again, it's not being multiplied by an I, so that's the real part. So what we do in these equations with complex numbers, we set the reals equal to each other, and we set the imaginaries equal to each other. All right, so right here, we're going to take 3x, oops, let's stay with the orange. So we take 3x, why didn't it do that? Hold on, give me a sec. There we go, now it'll do it. 3x minus 5, and we're going to set that equal to the real part over here. So what's the real part over here? It's the 7. So I just take the real stuff. It doesn't matter if it's x or y or z or whatever. We just take the real numbers over on the left-hand side, we set it equal to the real numbers on the right-hand side. And we're going to work that out. We can do that in a second. Let's keep setting this thing up. Now we're going to take the imaginary part of the left-hand side, of the left-hand side, and set it equal to the imaginary part of the right-hand side. So we're going to go y minus 3, we'll keep that in parentheses, times I, and that equals, what's the imaginary part over here? Is just 6i. So now what we're going to do, we're going to get two answers. Well, we got two variables, so it makes sense. We have an x and we have a y. So we're going to solve for x and y. So I'm going to add a 5 here, add a 5 here. Oops, that's a 5. And then divide, or not divide, subtract, or add, I guess, equals, what's that? 12, divide by 3, x is 4. Okay, so that's one of my answers. We got to come over here and do the same thing with y. So let me just make sure I did it like this. Okay, we could do this. Now this works out really nice and easy because look, this whole thing is being multiplied by I, this 6 is being multiplied by I. So what I can do is I can actually divide both sides by I because this is being multiplied, so I can get rid of the I here and I can get rid of the I here because this was being multiplied, this was being multiplied. So basically, I divided both sides by I. I just didn't show it. I just crossed them out, okay? So if you divide both sides by I, they go away, and now look what you're left with. Super easy. Y minus 3 equals 6. Add a 3 to both sides. Y equals 9. And that's your answer. It's basically Algebra 1 kind of stuff, okay? The only thing really different here is that you set the reals equal to each other, right? So we set this equal to this, and then we take the imaginary stuff and we set it equal to the imaginary stuff over here. Once you do that, it's super easy. Now look, these i's aren't always going to cancel out, just happen to do this on this real easy problem. Let's do just do one more, okay? I was going to do a couple more, but we're running out of time. So let's just do one more. And let's go with this color right here. Actually, it's one more example, but there's two parts to it. So here it is. Now this one just says simplify. We're not actually solving for x. It's just basically an addition problem. So you should get the idea that when you add things together, you can only add the reals together and you can only add the imaginaries together. So we're going to look at this and just add the reals together. So which one is the real over here? It's the one that's not being multiplied by the I. That's the 5. So we're going to take that and we're going to add it to the real part over here. So all the real numbers, basically just the whole numbers, the ones without the i's with them, you're going to add together. So we could do that. So we're going to have a 5 plus 2. All right, so we got rid of this and rid of this. Remember, this is an addition. Even though there are parentheses here, we're adding all this stuff together. And now let's add the imaginary numbers together, the ones with the i's. I mean, this is Algebra 1 stuff. If this was an x, you wouldn't have any issue with it, all right? But they're i's this time. So it's negative 7i plus 4i. So negative 7i plus 4i. Always do the reals first. 5 plus 2 is 7. Do the imaginaries. You do them just like you would do them if they were variables, okay? So negative 7i plus 4i is negative 3i, and that's it. Don't change that into a square root of negative 1. You don't have to do anything with that. It's perfect the way it is, and that's our answer. All right, let's do another one. 4 minus 8i. So really, on that first example, the parentheses were not necessary. On this problem, one of the parentheses is absolutely necessary. All right, so if you look at this negative is being distributed, just like it was a regular Algebra 1 problem. So let me go pretty quick here. Distribute the negative through both of these. So it's negative 3, and then it's minus a negative 6i, which is a plus 6i. That was really super easy stuff right there. Now we take, this is the stuff that we learned today. We take the reals and you add those together, and you take the imaginaries and you add those together. Let's just do this in our head. I don't think we have to write that step down. So we got a 4 and then minus 3. 4 minus 3 is 1. Negative 8i plus 6i is negative 2i, and that's all you can do. You're finished. Okay, you can't simplify that I any further. Yep, that's basically where I wanted to end anyway. Okay, we only have one more, well, two more examples, but one big example, example 7. So we'll do that tomorrow, whether we're virtual or we're in school. That's what we're going to do. So here is your homework. So your homework, it's section 5.4, and it's page 280, and it is number 19 to 31 odd. Okay, so there it is right there. Write that down. Now, I am recording this, so I'm going to try to figure out how to put this on Teams. So if you need to go back and look, then you can do that. This is the first time I've tried recording something, so I don't know if it'll work. We'll see how it goes. But let me bring up the Teams. Everybody got that? It's page 280. It's 19 to 31 odd. All right. So, let's see. Yeah, this doesn't. Oh, if you go to your regular team, here's the deal. Yeah, if you go to this, okay, so if you go to this window right here, you do have the book. I put the book here. So if you go to this part of Teams, you should have something that looks like this, I believe. I really haven't seen it from the student's point of view, but I believe you have something that looks like this. Right here, see at the top where you go to Files, and you'll see all these files on here. What you can do, right, there's a test, there's a quiz, there's a whole bunch of other stuff that Mr. Rao put on there, but I put this on there. This is the chapter, this is chapter 5 of the book. So you could download it. Watch this. If you click on this check arrow and then come up here, it says download. You could download it to your computer, and I would do that. It's not a real big file. It's only one chapter, so it's not a super big file. But if you decided not to download it, you could always just click on it. And if you click on it, it takes a second, and then there it is. Now see down here, it's going in circles. It just takes a little bit of time. There you go. There's 84 pages in that chapter, and you can just kind of scoot down and find what you want. All right, so you scoot down. What are we on? Oh, it's 5.1. We got to scoot down a whole lot more. And you could actually, I believe you could type in the number. So what did I say, 280? Oh yeah, a couple more pages. Oh, I'm going the wrong way. Can't see with my glasses on. All right, so there it is right there. So there's your homework right there. I'll blow it up a little bit. Actually, it zooms in. Oh, I don't want to do that. How does it zoom in? Oh, I guess it doesn't zoom in on Teams. If you download, oh, there it is. Yeah, you can. Watch, you can zoom in, and you can pick how much you want to zoom in. There you go. Cool. So there you go. There's the problems that I'm going to have you do. Now, I did ask you to do, let's see, there we go. 19 to, what did I say? 31. Yeah, you should be able to do everything. Now, they do put some problems. See this problem right here? This is multiplication. We didn't do an example like that because they didn't have one in the book, but it's just FOIL method. Just do the FOIL method, but you're at the end, you're going to get a 2i times 2i, which is 4i squared. Remember, I squared is just -1. So even though I didn't do an example like that, for some reason they didn't put one like that in the book. They should have, but that's what you're up against here. All right, that's it. Everybody good? All right. Well, you enjoy the sleet and the rain outside, and I'll see you tomorrow, whether virtual or whether in school. So we will see you. Any questions? Anything before we go? All right. See ya. Have a good day.
All right. Bye, Mr.
Thank
Amber.
you.
See you guys.